following routes that I can get. Okay.
Awesome. Yeah. So let's get started. I think before we get to the items of the agenda, I do want to cover one announcement. So we have the Triton conference planned mid-September. It's going to be in the Microsoft Silicon Valley campus. All the details are still being decided. The speaker list is still being decided, but we will get word out as soon as we have everything planned. We'll get the registration and agenda out in the next coming weeks. So please stay tuned and reach out if there are any questions or concerns again. So with that, let's jump into the agenda. The first item was alternative backend development approach. We have AMD, Intel that is being requested. So I think there was the question around what is the roadmap, what is the public roadmap for these backends, and then what is the plan going forward in terms of timelines, in terms of what backends are going to be supported, etc. So Phil, do you want to get started on that?
Yeah, I can speak. First of all, can everybody hear me?
Yes.
Okay, I can get started on that. So I guess also, like, before I start, feel free to interrupt me anytime for any questions that you think is relevant, because I might forget to mention things. And I think it's good if this community meeting can sort of be more of a Q&A than a one-directional update. So concerning alternative backends development, so we're talking to a lot of people, and some have not gone public with the backend, so I probably cannot give you the full list of everybody who's working on one. But AMD is definitely one. Intel is another one. And I think the plan right now is for more major updates to come at the Triton developer meetup in September that was just announced. That there's been pretty good progress on both sides from AMD and Intel. One sort of major design change that has happened is concerning external backends. We've made the decision to not upstream them directly yet, but to have sort of a staging state where backends would be used by the Triton upstream repo via plugin mechanism that was developed by Intel. And so this will be the primary mechanism for us right now. Just sort of the motivation behind that is just to free up bandwidth on our side and to reduce the maintenance burden for the NVIDIA backend, so that we can still provide prime support for that. I think for to Vinod's question, it will be in person. Well, it will be both in person and virtual. It will be a single day in Sunnyvale, if I recall correctly, where the Microsoft campus is.
Mountain View. Yes, Mountain View.
Mountain View, sorry. And and it will be also like accessible virtually, hopefully pretty liberally. And and there will be recordings as well. The exact details of the format have not been completely worked out in terms of like how many how many talks there are, how long the talks will be, and so on. But that will at least include updates from AMD and Intel about their backend, and pretty much any hardware vendor who want to provide an update as well, including NVIDIA, of course. This.
Phil, there was a hand up. I think I can't see it now, but whoever it was, do you want to ask a question? Was it Dan? I think
that was Vinod's.
Okay, it was Vinod's. Okay. Yeah.
Intel. Sorry. Intel refers to the Intel GPUs for now. So I think. I think some Intel people are here. So maybe Akan, do you want to speak a little bit to the Intel backend? I think you're muted.
Deacon, you are muted. We can't hear you.
Oh, sorry, I muted.
Yeah, go
So
ahead.
could you hear me?
Yes, we can hear.
Thank
Yeah.
you. Yeah. So yes, just as Phil mentioned, we have landed the Intel GPU XPU backend to the Triton as the out of tree backend, and by now we have passed the most the Triton unit tested cases, and we take the PyTorch inductor benchmark suites at the end-to-end test cases to measure the end-to-end model pass rate and to measure the performance. Kind of now, yeah, we made some good progress and get some promising performance. Yeah, in the future we can share more details. And yeah, and I think the Triton currently is more attractive is about the dot optimization. Currently, we are also working on the dot optimization in the future. And besides that, I also have some open about the CI, how to enhance the CI progress. We can, yeah, discuss more at the coming agenda. I think according to the agenda, there's a dedicated agenda for that, right?
Yes,
How
there is a
to,
topic. Yes. Yes.
yeah. Anyway, thanks for Phil to great support to land our PR. Yeah.
And just to respond to your question, this is not just an Intel Arc. We have a number of GPUs, and so we're not limiting to just one.
Mm-hmm.
Okay, and about AMD backend, I don't know if someone's from AMD in the chat can like or raise a hand. But otherwise, I can give a quick update, which is that their backend has been progressing pretty quickly. It's in a public fork, just like the Intel backend, so anyone can try it if they want to. And now it's they have like tensor core supports working out quirks about like dense math performance that has not quite yet reached the CL Blast level of performance, but that there's been work also like the Triton Flash attention forward pass also works on AMD backends now with the pretty reasonable performance in tensor cores. So there's been a lot of activity there as well, and this is also for AMD GPUs specifically, and more specific for their like AI accelerator GPUs, the MI 250 and MI 300 that was announced recently. I don't have much else to add with respect to backends.
So Phil, there was also a question about general public roadmap. Do we have timelines that we want to share for anything?
I think the coming up with a long-term roadmap has been like pretty tricky, just because like I think priorities change very quickly in that field, and historically it's been the case that like our road like let's say if we had put on a roadmap 6 months ago, this is probably not what we should be doing right now, given all the changes that happened. So I can speak to the short-term plans, which is until the end of the summer. So right now we're like very focused on Hopper support, and also improving all FP8 stuff, even on Ampere. So this is where most of our effort are. And once Hopper proper Hopper support lands, will define the next set of priorities that will probably include like some refactoring of the code base to just to increase maintainability. I say this is pretty much the roadmap right now, but we don't, and of course like all the other backends, but and the timeline for Hopper, I think end of August, we'd like to upstream our Hopper support.
There was a question from Manish.
Yeah, so I hear Phil say FP8 support on Ampere. One is that, and then by end of the August, what all you're planning to complete on Hopper support?
Yeah, so FP8 support on Ampere, what I mean is being able to run FP8 manuals at like peak FP16 throughput without extra memory consumption. So that it's already sort of the case that it works as long as in the row major for the left-hand side and column major for the right-hand side. One more thing that I'm doing right now is making sure it also works for attention. So you can do attention with FP8 QKV, flash attention with FP8 QKV, and have the nice casting to FP16 happen just in places before data is fed into the tensor cores. So this is what I mean by FP8 Ampere support. And the other question for what we're planning to do on Hopper by end of August, it's not entirely clear, but we'll make use of at least the 4th gen tensor cores and the TMAs, and also the CTA clusters.
So TMA with multicast and clusters.
Yeah. And the plan also for Hopper is that there's going to be a small, like, not really a programming model change because things will remain backwards compatible. But in order to unlock full Hopper performance, you'll have to use the new block pointer abstractions, which we have like a couple of tutorials about. Will enable the use of TMAs, and also like when we upstream Hopper, a Triton program ID will no longer map to a single thread block, but to a thread block cluster, and then the distribution will be handled automatically by the compiler. So that this is like the general plan for Hopper. And for the backend, I don't think that includes Apple Silicon at the moment. Apple is free to work on that if they want to.
Will there be any DC breakages from the changes?
We plan not to. Yeah, there's some minor BC breaking change that we want to do that were things that were very poorly designed at first. Like, for example, when we set the number of warps and the number of stages, right now it's just like as extra keyword for the kernels. But we sort of wish it could just be like passed with the grids in the index operator overload that we were doing. I think that would be much cleaner. So that's probably the most immediate BC breaking change that we have in mind. Other than that, we're trying our best not to break backwards compatibility for Hopper.
Okay, thanks.
Okay, any other questions on the topic of roadmap or backends? Okay, then let's move on to. Sorry. Yeah, go ahead. Yes, please.
So hi, this is Javed from Qualcomm. There was recently a Triton to Lineage diff from Microsoft. I was wondering, what's your view and on that front?
Yeah, so I guess I can speak to the potential like view in terms of integration. For that, I think Ian, who developed it and proposed the PR, is also in the call if wants to talk about the technical details. Yeah, I think that there is currently no plan to upstream it for the same reason that we are not upstreaming AMD and Intel backend, just because we have limited developer bandwidth and we want to focus very, very tightly on NVIDIA GPUs. And also one thing that we hope will happen is like to sort of have like an ecosystem around Triton with like people developing these really useful passes that other people can use in their backend. So currently that's the plan. The PR is there, and everybody can see it and take a look. And I'm sure a lot of people have found it very useful in developing custom third-party backends. But it's likely in the short term to stay out of tree.
When you say short term, do you have some kind of timeline in mind, Philip?
At least 6 months, but probably much longer. I think the upstreaming will be considered more seriously once we think NVIDIA backends are super stable and require very little maintenance effort, which will take some time. Or of course, whenever NVIDIA loses their dominating market position, which might take even longer. But yeah, I think right now NVIDIA GPUs pretty frequently change their programming models. Like Hopper was a major refactor, and we don't want any external effort to sort of slow down NVIDIA support, to put it bluntly. So this is the rationale behind this decision.
Okay.
I have a comment. First, if Triton gets more generic with more backends like AMD and Intel, then hopefully the changes in NVIDIA support will be easier to implement because you have more generic higher structures, and then you just change the little things. So if as you add more support for newer NVIDIA GPUs, if you make the support for the generic concepts more generic, then it is going to be easier, not just for NVIDIA GPUs, but also for other architectures like AMD and Intel.
I think, yes, go on.
Yeah. No, go on. I have another question, but it's different. Yeah, go on, your answer.
I was going to say, I think that in theory is very true. I think in practice, if you really want to reach peak performance, like same level as Kubeless and Cutlass on NVIDIA GPUs, there are some very NVIDIA-specific things that we have to do. And these things are like pretty well reflected in the IR. Like for example, the ISA, of the GPUs, like the way NVIDIA handles asynchrony right now is very different from the way first of all, other GPUs don't have asynchrony right now, but from the way like MI300 will handle it. So I expect a lot of the friction to happen around like handling of asynchronous operations, and in particular, all the warp facilitation stuff that is done on Cutlass, for example, is another thing that will be very hard to write in a generic way that is applicable to other backend. It's possible though that like in a couple of years, there's sort of a convergence of ISAs, and that we'll be able to have generic abstractions there. Then, but I think for the next couple of years, I think it's quite unlikely that we'll be able to reach peak NVIDIA performance with fully generic abstractions.
Yeah, makes sense. So the other thing on the Triton to Lineage conversion, I think it makes a lot more sense to make Lineage to Triton rather than the other way around, because it's higher to lower rather than lower to higher. So have you looked into this? Is this a thing that you guys are planning to do?
Well, I think on the question whether it makes more sense, I would defer that to Ian Berman, who wrote the backend. On the separate things of whether we've considered the Lineage to Triton, I think it might be something that it's maybe a question for the XLA people, I guess. So I don't know. Ian, do you want to talk about the decision to do like Triton to Lineage?
Yeah, sure. So I think Lineage to Triton actually is an interesting idea. We've done some experiments actually, not on my group, but in other groups of Microsoft with that. It was similar, trying to lower things into Triton. And one of the things we found is Triton isn't quite expressible enough to do that. So we need language changes, I think, to represent some of the tiling that things like Lineage can produce. The other way, though, that we're really interested in the Triton to Lineage path, because I think it enables a lot of third-party backends to wire up to Triton, right? Because we have a community of folks already in MLIR that have been developing using Linealge dialect or dialects that are lower level than Linealge. And so if we can, as you sort of said, like raising Triton up to Linealge, then everyone else can bring it down and bring their existing MLIR infrastructure into the Triton ecosystem.
Okay, thank you.
I think there are other hands up. The credit card room, do you want to go next?
Yeah, going back to the question of backend specific operations, like, do we imagine that things more specific to NVIDIA's GPUs would get into Triton AR? Like, for instance, what about the force sparsity, which requires a separate instruction?
Yeah, potentially this could get into Triton GPU IR. For sparsity, sparsity is a little tricky because we haven't thought yet of like generic ways to present this in the high level language. Yeah, my experience with 2 force sparsity has been like pretty negative. But if like it becomes if it becomes mainstream, it's certainly something we'll consider seriously.
So I had a question, Phil, about metaprogramming support in Triton. So there was some discussion, and you said that it's not high priority at the moment. So I was kind of interested in some tooling and automatic generation of Triton. So the question is, do you or the community see any interesting use cases for metaprogramming or generation of Triton code?
Yeah, I think that there's definitely use cases. Like I've heard of people having to use like Python template libraries to generate like Triton source code, and obviously I'm sure we can do better than that. So I do think that there's some interesting things there. Interaction with the ahead of time compiler is a little scary, but yeah, I think it's also workable. So yeah, I think metaprogram support is probably in the realm of like it would be very nice to have for developer productivity. At the same time, it's some level of syntactic trigger that's still doable without it, with like very ugly workarounds. And the general policy of Triton so far has been to prioritize like things that enable higher performance, for example, or over things that like can still be done with enough working around.
Okay.
Javed, you want to go next?
Yeah, I had a request more than a question. On Renato's point about different back, and Philip, you mentioned as well, AMD, Intel developing, but it's not yet upstream. And then the question becomes, just like LLVM, like a lot of refactoring and code duplication just to, and then, so would it not be a good idea if it was sort of, I mean, of course, we don't have limits on different backends upstreaming, but the refactoring that's needed so that they all integrate well seamlessly, rather than people rewriting in different ways. So what's your thought on that? That would be good, because if we come in and we write our own backend, we will write it in a slightly different way and may not merge with AMD and Intel, how they would refactor some of the common stuff.
So the plan is for the Triton IR part to be stable. I really doubt we can make Triton GPU IR generic and not waste performance of an NVIDIA backend. So I can tell you, like, my big fear is that we try to make the IR generic and it works perfectly on say, we could have done this like a year ago, we can do this that experiment. A year ago, we have a backend that works perfectly on NPR GPUs. Well, perfectly is a strong word, but that works pretty well on NPR GPUs. And we have like AMD, Intel, other partners who are potentially interested in writing the backends. Let's just like make our abstractions more generic. And I think at the time it was doable. We could have done it, and then we do it, and then we upstream AMD and Intel backend, and then Hopper comes out. and then it becomes a huge nightmare to add to get peak performance on Hopper without breaking the other backends. And I think right now it's true on Hopper, and even if we could do it on Hopper, I think it would probably break again at the next generation of NVIDIA GPUs. So I think this is my biggest fear, is that we could, like, by trying to be too generic, lock ourselves into a corner where it will become very, very difficult to provide performance improvements. And I think this is a lot how, like, projects like Triton could, like, eventually die, is like lose their edge over handwritten CUDA through, like, very generic abstractions. And if that happens, then I think the value of Triton becomes much lower. So being able to match handwritten CUDA has always been our top priority, and I do think, like, upstreaming other backends gets in the way of that to some extent. So yeah, so the solution we've found is to provide a layer at the Triton IR level that's sort of generic, and so other backends can plug into that. And that also worked for, like, high-level language that would generate Triton IR. And once they've plugged into that, then we have this plugin interface, and we can package external backends with the Triton wheel so that users don't effectively see the difference. But yeah, I think right now it's the preferable solution. It's possible in 3 years if there's a convergence of the ISAs, similar to how there was a lot of sort of a convergence of, like, ISAs on CPUs that I think made LLVM, like, a little bit easier. Then I would be much more supportive of that.
Sorry, it's just to make sure that the expectations are met. LLVM isn't a success solution because the ISAs have converged. I mean, ARM and Intel and is just not converged. LLVM is generic because the IR is generic, and the backends used is genericity to produce good code. To me, it looks like you're tying your success of Triton into NVIDIA, which today it looks obvious because they have, I don't know, 90-something% of the market. But there are other solutions that eventually will percolate, as did Intel and ARM. I mean, ARM is now in the server space, etc. So I think this is a reasonable expectations that you're looking into the next 3 years. Fine. Now the question then is, okay, Intel and AMD and ARM are adding external alternative backends, and then they use the current NVIDIA and they map to their own ISAs, which is never going to converge with NVIDIA. Well, never is a strong word, but unlikely going to converge. Then you write something for Hopper that breaks all of their expectations, and so you're saying that it is now the job of all of the other backends to then change again their own backends just because for Hopper is better, so you break everything and then now they have to fix everything. So every generation of NVIDIA, all of the other backends will have to update to map the new instruction set into their own. Is that the expectation for the other backends?
So first of all, I think I might have misspoke. I think probably what I meant is conversions of programming models, which I think is true. Like, a lot of the CPUs have very similar programming models and similar ways of expressing things like asynchrony. And the reason why LLVM can have a generic IR is because there's a single programming model in LLVM that works for a lot of different backends. And the moment you change the programming models, like on CUDA, for example, then it becomes much harder to write generic LLVM that's performant. And I think right now the big problem between GPUs is not really convergence of ISAs per se in terms of the precise instructions that exist, but the fact that the programming models are actually much more different than they look. And if you look at, like, programming model of, for example, Cutlass 3, is very different from, like, if you look at things like warp specialized kernel, for example, and TMAs is quite different from other architectures. So I think that's probably the first part of the answer is, I think convergence of programming models necessary to reach peak performance is important there. Now, the expectations for external backends is actually, because we have this third-party system, the expectation is not that they would modify their thing to be compatible with the new abstractions. I think we still have the Triton IR layer at which we interface, and people can write backends for Triton IR in the same way that people can write backends for LLVM IR, because I do think that Triton IR is what proposes this common abstraction layer and common program model that works on different backends. But I don't think that Triton GPU IR is. And so I think what happens is that like anyone who wants to write a Triton backend can plug into the Triton IR and potentially use tools like Triton IR to Linalg that the Microsoft developed. And they could, like AMD, use some of the abstractions that we've made for Ampere GPUs in the Triton GPU layer. But I do think for the Triton GPU layer, it's becoming more and more of a Triton GPU NVIDIA layer. And some of the abstractions are very much suitable for MI250 and MI300 because I think to some extent it's similar to Ampere GPUs, but some of the abstractions like that we're developing specifically for Hopper will be completely unapplicable to AMD GPUs for a long time, for the foreseeable future. I don't know the plans for AMD in that regard. So yeah, I think this is the important part here. I think we have other topics, and we're already halfway, so maybe we can move on.
Sure. Let's move on to the state of documentation. So there was a question of whether it's is there going to be a planned effort, and if yes, then what is the priority?
I think, yeah, so there is no big planned effort on the OpenAI side right now to improve documentation, just mostly because we're like very short on staff. We're a pretty small team. We also have like other duties besides Triton. And so we're very, I think the OpenAI team is very focused on like abstractions of the backend, like improving abstractions and for NVIDIA GPUs and improving performance, fixing bugs, these kinds of things. For documentations, I also think we're not necessarily in the best place to write all kinds of documentation. I think there's some documentation that we've done, like some comments in the backend code in terms of how we simulate LD metrics, for example, for cases where it cannot be used, or mixed FP8 times FP16 matmul, for example. So this is the thing that we're actively doing, like commenting the code better whenever we refactor something. But for things like improving the tutorials, I think this is really parts where the community can be really helpful because new users are in a pretty nice place to know like what's missing in the current tutorials, which I think is a lot, and also what's missing in the current docs of the Python. I'm sure there's a bunch of like signatures that have changed and docs that were not updated, and currently like we could take a few days to go over like all the functions and fix them, but I think that wouldn't solve the core problem of the documentation, which is that like tutorials have become disorganized and like and there's like no way, like no tutorials on like tweaks that you can do, how to debug common issues, these kinds of things. So I think this is the parts where the community can be pretty helpful.
Yes, Ian, you had your hand up.
Yes, thank you. So I think my group has at least a few cycles to spare to try and improve things. Are there any particular areas in the documentation that folks would like to see improved?
I mean, I can think of some. I'm sure many people can post more in the Slack. I think one, yeah, I think as I said, the tutorials have become like pretty disorganized. And also, like I know like the documentation for some Python functions or the docstring are missing, and or like sometimes they're like missing arguments. At least sometimes they're missing completely. Yeah, so I think that these are like lowish hanging fruit that can be done. Yeah, I think that there's like there's like an entirely separate thing, which is more like a troubleshooting section, or like if you have like a bug, like I know Karen has been working on like some utilities to debug illegal memory accesses and a tutorial for that. So that's also another thing, is like some troubleshooting documentation, maybe tweaks to get like a better performance, these kinds of things.
So Ian, do you want to start a thread on Slack to collect more
I think
inputs?
someone just created a message.
Created, awesome. Okay.
Yeah.
Okay.
I will go look for it later. Thanks.
Any other comments, questions on documentation? Okay. I know, Javed, you have a comment about LLVM best practices. Was there anything else you want to add?
Sorry,
So,
I was
yeah.
muted. Yeah. I mean, like on top of whatever was said, I totally agree. Good documentation, and just because I'm not like saying MLLVM is better, I'm just saying they are much older, so they have done the wrong things and then done the right things. So on top of documentations was like tests which illustrate how to do things and how not to do things, and like whenever like people have questions on MLIR LLVM, they just go in the test and see, oh, this is how it's to be done. Having said that, I mean, the difficult part would be like, okay, it's all for NVIDIA GPU and how, but that's something we can work towards, how to write generic tests. That's my 2 pence.
Yeah. I think another thing that can probably be improved in some better docs for Triton IR. So right now, like we have a table gen, a TD file that table gen record with a bunch of comments that are like relatively explicit, but I think especially as we encourage people to plug into Triton IR rather than Triton GPU IR, I think it would make sense to also have like better Triton IR documentation, and also not only better, but also integrated in the rest of the Triton docs.
Okay, there's a question from Lab US Mountain View.
Yeah, so I just want to say, like, and as you're doing this, feel free if there's any enhancements needed to the doc generator for the table gen files. Please ping. I think we've been working on a few of those, making some small improvements, but it's always good to hear feedback about what is missing in the op documentation and integration. And we just went through integrating some of these, at least like Erie side as well. So I do find it quite nice to be able to see the IR ops all documented.
Okay, I do want to move to the next item, which is related in terms of what is the channel that we want to use for discussions, smaller technical discussions. So I know we've spoken about Slack just now to use, but then there is also the channel of the challenge of discoverability with Slack channels. Do we want to take smaller technical discussions to GitHub and create discussions where folks can contribute, as well as it can just be searchable by others? Like, are there thoughts or opinions?
I think Slack is great. I think the problem of discoverability can be like solved by like making the Slack more discoverable. I think the issue would be like, right now it's not like 100% open. Like if you want to join this Slack, you still need like your shared invite. So I think there's been this janky mechanism of like having a link sort of passed around. Having a better way to invite to get people into the Slack, sort of how like it can be done in Discord. I think it's probably a way to partially solve this problem. On Slack, that there is the hashtag dev channel that was made for this purpose. I don't think it's being like utilized super heavily, but it's there. I know for like OpenAI people, the Triton Slack is just a much more convenient way to answer questions.
Sorry. Go ahead, whoever that was that spoke up.
Yeah. It feels kind of janky that like most of the time we only get 90 days worth of messages. Yeah, thoughts on this? I don't know. I got an ad in the UI saying that it's only $500 a month now. So anyway, I have no idea.
Yeah, I think if it's $500 a month, it's probably like worth going to the pro. I think last time I looked, which was like when I made this like a year or two ago, that was like per person. So that was like a little bit more scary. But per person per month.
It's like $825 a month per person, which was like it's like $1,000, and they have some kind of free like cheaper deal.
Yeah, we can look into that.
Great. It's just like there were like enough times where it's like I'm like very sure that there's like discussion on this issue, like that this bug had been solved, but like I cannot find it.
Yeah, I agree. Yeah, Discord is another option that sort of doesn't have these limitations natively, and I know like some, it's like there's fragmentation in terms of what workspace people use. Some people use Discord for technical things. Some people use Slack. I think we can talk about this offline with some people.
Ian, did you have a comment before we close?
Yeah, just wanted to add, like, wherever we probably, converge on what we want to do here, we should make sure that we publish it a little bit more visible in the GitHub, because I think awareness is important of like, hey, here's an area where like there's a discussion area in GitHub, but we're actually having our discussions elsewhere, so folks can find that stuff. Because right now, I think, like to mention discoverability, but just in general, I think there's a lot of issues that are open on the GitHub, and there are a lot of discussions going on. So we already have 2 places for things. So if we create a 3rd place, I don't know if it solves any problems.
Yeah, well, I think if there's a Discord, that would replace the Slack. But I think that the way I see it, GitHub and Slack are like 2 different modes of communication, though. Like Slack, I guess you can see have like long threads on Slack with like lots of message. But I think I guess it's also a matter of personal preference. Yeah, I think historically the nature of discussions on the GitHub has been like a little bit different and more like more technical maybe, but maybe not actually now that I look at it. Maybe the GitHub discussions is redundant, and everything should happen on Slack.
Okay, I know there are some questions around sponsorship for the Slack channel, etc. I think let's take this offline, Phil. We can maybe converge on what to do in terms of the best mode of communication. Moving on. So this is about CI, improving CI and conformance testing for validating new backends in terms of stability testing and regressions.
So I'm not sure if this is like new backend specifically or CI in general. I can probably talk about both. So we've been like improving CI a little over the past few weeks. Like, Thomas made sure the PyTest could be parallelized, so now the CI works much faster. Another thing that we can sort of do is just allocate more GPU resources to the CI. Right now we have like 1 GPU of each, one like A100, one H100 that we use for the CI. So these are like things that can be done. Also, I think just having like more coverage is also good. So it's also something that we're like pretty actively doing. Is when I was mentioning the float 8 thing I'm doing, and I'm also adding like more CI tests in the process, and I found flash extension didn't work in FP8 when I added the test for it. So I think we're taking testing very seriously, but testing compilers obviously is a pretty difficult task. But yeah, I think in general we've been like also pretty liberal in terms of accepting just like regression tests, like things that just like trigger an issue, and then upstreaming, just adding this as like an integration end-to-end test to make sure it doesn't break again. So these are all the things that we're doing. Now for the new backends, so because it's third party and we don't want to be in the situation yet where like a failing new backend test, failing external backend test would like block merges into the main branch. We're planning to have CI through nightly wheels. So essentially, whenever we build the wheels nightly, which the wheels job is now revived thanks to Microsoft. Whenever we do that, we're also going to build the wheels for external backends and also run our battery of tests on an external backend. So that's sort of the plan for testing is to have like extensive battery of nightly tests for external backends and very lightweight front-end tests, just to make sure, for example, that an empty kernel still works on external backends, so that like we didn't break the interface with third-party backends, because although like we want to take this seriously, if we break this interface and we want to fix this is the kind of thing that should block merge to master. So this is the plan right now for the CI.
Any comments there? Javed, I knew you had a CI question. I don't know if this covered what you had in mind.
Sorry, no, I did not.
Oh, okay.
Sorry,
Okay.
no,
Maybe it was someone else. Okay, sounds good.
Sorry, I
It
have
was
a question.
Icon? Yes, it was Icon.
This is
Yes,
here.
yes.
Yeah. I have a kind of have a question kind of related to the CI. So, I'm not sure if Triton has defined a clear release process. So, when to code freeze, when to release branch cut, right? So because we need to prepare, we need to ensure we pass most of Triton unit test cases or some end-to-end benchmarks with the Triton release, right? So if there's a clear release process, and we can, it might be very helpful for the third-party backend to ensure its quality and performance.
Yeah, I agree. So I think we don't have a formal release date planned, but I think that the general plan right now is to have a release sometimes maybe in September, October, like after the meetup, and when some of the Hopper stuff is upstreamed, because I think so most likely we'll try to synchronize with the Torch release that that comes after the Hopper support is upstreamed.
Okay, so for a dedicated for a particular release field, do you think we need to, for example, submit some test report to you to review the third-party backend quality or performance?
Yeah, I think it's helpful. At the same time, I don't want I want you to be able to define your priorities quickly, and like I mean on your own terms. So if you think like improving mathematical performance is more important than fixing like a flash attention backward bug, which is a choice we have made before for A100. Then I think you should be able to do it, and I shouldn't be the one that tells you what to prioritize. So that's kind of my view on it. Is a perf report are nice to see, but I won't be trying to like. I think performance report to me are more important than correctness report. So I think what would really excite me would be like you're matching like proprietary kernels and like dense matmos or something, because I know what it takes, and if that happens, I think that's very good. And if there's like instabilities elsewhere, that's sort of your decision to make. So yeah, so that's kind of my general thoughts on it. It's just go at your own pace, and we'll package the third-party backend like sort of no matter what. I think as long as you want us to package it, and yeah, and then I think we'll probably have an error message or something when third-party backends are used and people face some kind of like error, to sort of like redirect the out of tree repo rather than the main repo or something. I haven't worked out the details, but that's sort of my general thoughts on that. Does that answer the question?
Yeah. Yes. Thank you.
Okay, so we do have a lot of other items, but we have 5 minutes remaining. I wanted to give it to anyone who had any urgent question or anything to discuss. Else we'll just go back to the next item.
I think maybe one thing I can do is try to cover the remaining items quickly in 5 minutes to provide a...
Sure, that works, yes.
So yeah, so language improvement / pain point. I think, yeah, one nice thing that's coming up is like the tool that Karen developed to like have location information in Triton generated code that allows us to trace back the source of out-of-bound memory accesses with CUDA GDB and NVIDIA GPUs and other debugging tools on non-NVIDIA GPUs potentially. Yeah, I think the rest of the pain points, yeah, I guess that's something where the community should just tell what the pain points are on the Slack. There are some as well. For Windows support, yeah, we're looking into it with Microsoft. I think the changes required might be like fairly small, but eventually it's all a matter of like resource allocation, human resource allocation. And I think if it's important enough, it's something we could like seriously consider, because it's not just like one-off support, but Windows support entails like maintenance costs and also like building wheels and these kinds of things. I think the known and anticipated changes for H100, it's something I covered a little bit earlier. So probably like in relative great depth. So to summarize, preliminary Hopper support are going to include like thread block clusters, TMAs, TMA multicast, and also like the new generation tensor cores. There are more experimental things that are being worked on for like warp specialization kernel, persistent kernels, and so on. And this is the part where I think it will be hard to have like very portable things with other GPU vendors. And yeah, the rest of the area. So int8, as far as I know, should work with tensor cores and have pretty good performance. It's something that Da Yen did like a year ago. And SM75, SM75, yeah, it should work, because if it doesn't work, it's bug. I think it may not work at peak performance because an SM75 is a consumer GPU that caps FP3 to accumulate teraflops with tensor cores, and Triton just use FP3 to accumulate for the TL dot. So there may be performance issues, but I think it should work. And if it doesn't, please report it on the Slack. Device functions. Yeah, so basic device function support was coded in by Karan a couple of months ago. Yeah, it's right now there's some restrictions like the device function can only take scalar arguments, and it's pretty tricky to lift this restriction. It's not really a priority right now, although device function can help work around some compiler issues and help reduce instruction cache pressure. And finally, remove torch dependencies from the front end. Yeah, I think it's one of the higher priority front end items. There's been progress on that side, so I think right now it should be possible to use Triton.compile without torch at least. Although like it keeps breaking, so maybe it's not anymore. But it's in the plan to like at least add CI for the fact that Triton compile should work without torch. For all the runtime stuff, all the JIT stuff, I think it will be like it's possible, but I also think it's lower value to some extent. I think what's important for us is that you can import Triton and compile a Triton kernel without depending on torch. And for JIT execution, I think right now we only support like using the integration with torch in terms of implicit casting we do from torch tensors, for example, also like how we get the CUDA handles for the device in the context. We could potentially have other like front ends in the future, but right now it's not really a big priority. So yeah, I think I covered everything quickly. Let me know on Slack if you have like more questions. I think we're out of time. I'm just to answer the very last question. I have no clue what changes will be required for the GPU after Hopper, if this is what you mean by Broadwell. Yeah, so I haven't started looking into this at all.
Thanks, Phil, and thanks everyone for the discussion. The last few items were covered quickly, so if you do have any questions for that, please ping on Slack. And we'll have our next meetup next month. So we plan to do this monthly. Again, thank you, everyone. See you next month.
Thank you. Bye.
Bye.
Yeah. Bye.
Thanks.
Bye.
Thanks, everyone.
Thank you. Bye.
Thank you, everyone.